Okay, so good morning, grade 8 Mahati Science High School students. So let's try to go and let's try to answer our second problem for our lessons 6 and 7 for area and perimeter and surface area and volume of 2D and 3D figures respectively. So it says here, we have this problem. What is the radius of the largest sphere that can be placed inside a hollow cone having a height of 4 and a radius of 3? Now, a hollow cone would look like a typical kind of cone that you see on ice cream stores. So it's a cone that has empty space inside of it. And then this problem is asking for the largest sphere. What's the radius of the largest sphere that we could fit inside of this ice cream cone? Now, in order for this to be the largest sphere, the it has to touch some of the side measurements or some of the surfaces of the hollow cone that we have here. So in order to visualize this problem, let's try to name some points. Okay, so we have here point O. That would be the center of our sphere. This is going to be point A. This is going to be our radius. We also have point B, which is also the radius of the hollow cone. We also have a point C, and we also have a point D, which is also a radius and is forming a right angle. Okay, forms a right angle here. Okay, so first question, where did this right angle come from? So as we can see here, if we've formed a sphere, okay, and technically there should be a circular part to this. If a line segment or if a line segment is tangent to any circular object or to a sphere, it can form a 90-degree angle here. So this could be perpendicular. And we can also form a 90-degree angle here. So therefore, for this figure, we have two right triangles. We have two right triangles. So let's try to write our two right triangles. We have triangle CBA, and then we also have triangle CBA. We also have triangle COD for this one. Okay, triangle COD. Okay, so let's try to write our givens here. The height of the hollow cone is equal to 4. Okay. So this means this is 4. And the radius of the circle of the base of the hollow cone is 3. Now, if this is 3 and this is 4, we can find the lateral side measurement of BC. Okay, since this is a right triangle, we can use the Pythagorean theorem in order to find the hypotenuse of this right triangle that we just formed a while ago. Okay, to solve for the value of BC, solving for BC, so we have AB squared plus AC squared is equal to BC squared. Since we know that AB is 3 and we know that AC is 4, the radius of the base is 3 and the height of the hollow cone is 4. That's going to be equal to BC squared. So that's 9 plus 16 is equal to BC squared. That's 25 is equal to BC squared. And therefore, the measurement of segment BC, or line segment BC, is just equal to 5. Okay, so this is 5 units. Okay, now, for this problem, we're going to use a concept that we will discuss in the third quarter. But right now, we're going to use it for this problem. So this concept is called similarity. Okay, so when we have similar figures, what do we mean? For similar figures, they should have the same angle measurements, but they would have different side measurements. You can only say that two figures are similar if they have different sizes, but they retain the same angle measurements for all angles inside of the polygon or the triangle. And we're going to discuss this a lot in the third quarter. So what are the two similar triangles that we have? So they would be our two right triangles. And the similar triangles that we form, we can create relationships out of the line segments that we have formed based from the naming of the triangle that we have. Now, if we have here two similar right triangles, so we can say that if this is R and this is OC, therefore we can find that the measurement of OC would be 4 minus R, right? Because we already have the value of R there. And we have BC is equal to 5. Okay, so 4 minus R and 5, they are both hypotenuse. They are both hypotenuse of R. They are both hypotenuses of our two right triangles for CBA and COD respectively. So for this problem, what proportion can we create in order to find the value of the radius? So for this problem, let's try to write our figures here. So we have here again, we have here B, A, C, where A is our right angle, AB is equal to the radius, okay, and BC is equal to 5. Okay, and we also have another figure here. Okay, so if we're going to write the second triangle, it should be ODC, right? Since D is the right angle here. Okay, and since we already know the value of OC, so that's 4 minus R, and we know the value of OD, that's the radius, so that's also R, and DC is missing. So therefore, we can create a proportion in order to solve for the value of the radius for this problem. And what would that proportion be? Okay, so since we know that the values of the radius is equal to 3, therefore we can say that OD is equal to 3. And for this problem, since the two hypotenuse are similar to each other, so we can equate them. That should give us a proportion of 4 minus R all over 5. That should be equal to R all over 3, okay, for this problem. So 4 minus R all over 5 is equal to R all over 3. Then we can cross multiply in order to solve for the value of R. So that should give us 3 times quantity 4 minus R is equal to 5R. Okay, so distributing 3 from outside of the parentheses, so that should give us 12 minus 3R is equal to 5R. So 12 is equal to 5R plus 3R. That should give us 12 is equal to 8R. And if we divide both sides by 8, so therefore the radius is just equal to 12 over 8, or just simply 3 over 2. Okay, so without directly solving for the radius of the circle, we managed to find it by using the properties of tangent lines being perpendicular to circles, okay, and also the Pythagorean theorem, and most especially the concept of similarity. So this was one of the most central concepts that we use in order to find the value of the radius. The radius of our sphere, okay, the radius of the largest sphere or the largest ice cream cone that you can place inside of a hollow cone would be 3/2 or 1.5 units. And that's the answer to our problem for this question.